So this topic from C2, it doesn't come up that often, but when it does, it's worth a lot of marks. So it's a good idea to understand. And it's when you're looking for how to find the biggest or smallest something can be. So optimising is max. So you're looking for maximum volume, for example, or maybe minimum surface area, or something like that. Something like that. You're trying to solve. So here's an example of the sort of thing. We have the question, what is the maximum volume? So this is optimisation. What is the maximum volume? And the volume of a can is, well, it's the area of the bottom, which is pi r squared, times the height. So that's what volume is. Okay? So we're looking for the maximum. What does that make you think of, maximums? Maximums and minimums? Turning point, so where the derivative naught. So we need to differentiate and make it naught. So it's a sort of typical problem, but we have got this h. This is the issue. And the way we deal with that is that we will always be given a piece of information. So here is the fact. Here is the question, and here is the fact. And what we need to do is take that fact and turn it into maths, because it's no good in the form it's in now.
No.
And if we do that, if we get the fact and turn it into maths, then we'll be able to use that in this equation for volume, and then we'll be able to do differentiate, make it naught, usual stuff.
Yeah.
But we are going to need to deal with that fact, and that's the way that you will always deal with these problems. So here's the fact. It's that the surface area of the can is 600 centimetres squared. 600 pi centimetres squared. So I've opened up the can so we can look at the surface area. We've got pi r squared here. Pi r squared here.
Yeah.
This is 2 pi r because this bit across here, when you make your can, it's what wraps around there. So this bit is wrapping around here, and circumference is 2 pi r.
Yeah.
And so to get the area of this rectangle, it will be 2 pi r h.
Yeah.
Agree? Okay, so the surface area is 2 pi r h plus pi r squared plus another pi r squared, and we're told that that equals 600 pi. So this is the fact that we need to find the fact, deal with the fact. Okay, can I simplify this? Yes, I can divide everything by pi. I could divide everything by 2 as well. And the idea, the whole point of this was that I want to extract this h information. So RH is 300 minus r squared.
Yeah.
So h, that was my problem in the other equation, is 300 minus r squared over r. Is that right?
I agree. Yeah.
Okay, so this is the fact, and this is what the fact has given me. Fact leaves here. And now we can use our fact. So, that's what we've got. We've got simultaneous equations, essentially. This was the question, this was the fact. We're going to put the fact into the question and sort it out. Do you want to do that?
Yeah, well, we already said, didn't we, that h was equal to 300 minus r squared over r.
Yeah.
And since the h is what we want to get rid of, it stands to reason that if we write it in the form of everything else we still want to keep, substitute it in, we have to get rid of it, don't we?
In here.
Yeah. So v is pi r squared h, which we've worked out to be 300 minus r squared over r.
Does that simplify at all?
Well, that r, because everything's multiplied together, that r will cancel with one of those r's there. And then we could multiply everything out, I guess, couldn't we?
Yeah.
Which would be 300 pi r minus pi r cubed.
Yeah, I agree with that. Just to slow it down a bit, in case someone's thinking, oh my god, what are you doing? What we had here on the top is pi r squared times 300 minus r squared, and on the bottom we have 1 times r.
Yeah.
So it's thinking of it like that. And then if we do divide by r on the bottom, and divide by r on the top, then we get 1 on the bottom and just a pi r on the top, and then you can expand that out.
And this is one of our little lozenges here, isn't it?
Yes.
So we're not actually, we're looking at that as one unit that we can't yet split up.
Yeah,
So we've got a pi times by an r squared times by 300 minus r.
yeah,
So that's why we can cancel across some of those r's, because they're just multiplied together in each
yeah, and then that gives us this. And the reason we wanted to do that was that we were going to do our normal thing where we're saying maximums and minimums, turning points, that's where the derivative is naught.
Yeah,
So we're going to differentiate this.
that's new.
It is, yeah, well it is and it isn't. If we have y equals a function of x,
Yeah.
we have dy by dx, so v is a function of r, dv by dr. So the r's got a power of 1, that comes down and times is by the 300 pi, then decreases to naught. The 3 comes down and then decreases to 2.
Yeah.
Anything to the power of 0 is 1, so it's 300 pi minus 3 pi r squared, and we wanted this to be what?
0.
0. We want the gradient to be 0, exactly. Divide everything by pi, divide
so.
everything by 3,
Yeah.
so we'd get 100 minus r squared.
Yeah.
R squared is 100,
Yeah.
r is plus or minus 10.
I agree.
Yeah? Do I need plus and minus 10?
Well, you might do, because we don't know which one's our maximum and which one's our minimum.
Except for what is r?
Oh, well, it's a radius.
Exactly,
So
it's a
we can't
radius,
have
yeah. R is a radius, so r is bigger than naught, definitely,
Has to
so
be, yeah.
r is 10. So the radius is 10. So the volume isn't 10. I haven't found the maximum volume yet, have I?
No,
All I've found out is the radius
that gives us our maximum.
that gives the maximum volume, exactly. So if I wanted to find the actual maximum volume, I'd go back up to my equation for volume. Here it is. Put my 10 in there, and then I'd find the maximum volume. Yeah?
Yeah.
Okay, so we worked out that r is 10, that's the radius, so v is
300 pi times 10 minus pi 10 cubed.
which is,
Well, that's 3,000 pi minus 1,000 pi.
1,000 pi.
Said it right. It's
2,000
2,000 pi.
Fantastic. So that's the maximum volume. Yeah?
Yep.
Okay. Yeah. That's what I was thinking. How do we know it's not a minimum? All we did was solve that, and I thought the whole point was that that could be a maximum or a minimum, and that we don't know, and that we have to do a check, don't we?
We do.
So there's a way of checking. Do you remember what the check is?
It's a test, isn't it?
Yeah, it's the fairy test. Second derivative. So you get your second derivative, you put your r, or x, in our case r, is 10, in, and that will tell us what's going on. Yeah?
Yeah.
Okay, so what we need to do is differentiate the derivative. Where's the, where? This is a long way back. Here we, oh no, here it is. There it is.
So 300 pi minus 3 pi r squared.
300 pi minus 3 pi r squared. Yeah. That was the original derivative, yeah? Okay, so we need to differentiate that to create the test function.
Well, that's just a number, so that disappears.
Yeah, because that's r to the naught after
Yeah.
that. R to the naught.
And that's naught,
Yeah.
all of that, so it's not needed. Minus 6 pi r.
Yeah, exactly, minus 6 pi r. So this is our test function. We have to feed our r value in.
Right, so we knew r is 10.
Yeah.
And so dt by dr squared is minus 6 pi 10, which
Yeah.
is minus 60 pi.
Now what do we do with that information? You do the test,
Well, first off we say we know that that's less than 0.
that's it, and therefore,
It's not what you think it is, it's the opposite, so it's the maximum.
yeah, exactly.
That's what we want.
Yeah, exactly. So, in terms of a sort of general structure of how you solve these problems, you're going to have a question which is to maximise or minimise something, and you're going to have a fact which may be hidden, but you need to find the fact. You need to write the fact as maths, so rewrite it as a maths equation, and then we had simultaneous equations and we fed that fact into the formula for the question, and then that gave us something that we could differentiate. Yeah. Then we did differentiate and make it naught to find the turning points. That gave us our value of r, or sometimes x. Then what did we have to do with our r is 10?
We had to
Feed it back in to the thing we differentiated. So this thing, I suppose.
yeah.
Yeah. So not into the derivative, because we'll just get 0, but into the thing that we got here,
Right.
the function. So
The
after
different-
the thing we
differentiation.
differentiated, the thing we differentiated, so in our case v equals, or y equals, or whatever it is, the thing that came from the original question after we'd shoved
Oh, so
back in,
kind
it
of
was
the
this thing.
yeah. Whatever it was, we
The
then
thing that we're actually finding the maximum or minimum of. So differentiate it, make it naught, find r or x or whatever it is, feed that back into the thing, and then we know what the actual maximum or minimum is. But we need to check if it's a maximum or minimum. So we have to differentiate the derivative. And then we have to get him again, but now feed him into the second derivative to test. And if we get something, feed in x or r or whatever it is. And if we get something bigger than naught, we know it's a minimum. And if we get something smaller than naught, we know we found a maximum. So it's quite a complicated structure, and it takes
probably about 7
practice.
steps, isn't
Yeah.
it? But
And it's a lot of marks. If this comes up, it's going to be at least 1 grade, if not 2 grades, to be able to go through this process.
But the nice thing is it practices a lot of skills that
Yes.
you need in other areas of the topic as well. So if
Yeah.
you get good at it,